Hey, I've got another tutorial for you. It's a wrecking ball simulation. Uses animation nodes. Super dope, super fun. You're gonna love it. You're gonna love it. Stay tuned. No, don't stay tuned. We're doing it right now. We're doing it right now. All right, open up that new blend file. Delete the default cube as usual. Get yourself a cylinder, shrink it. No, get into edit mode. Let's go GZ -1. We're putting the pivot point at the very top of this thing because this is going to be the chord to our wrecking ball. So let's shrink it on not the z-axis, real small. Up to you. Ooh, real tight, real tight. Okay. I'm gonna, I don't know, this, I'm anal. I'm just gonna make this 0.0032 or whatever. Oh God. 0.03, something like that. And then we're going to increase it. Oh, SZ. And I'm gonna move it up. Cool. Then let's create a UV sphere. I'm gonna shade smooth. You can add a subsurf modifier if you want. It's up to you. This is your animation. Move this up, something like that. I'm going to click this, and then I'm going to shift click the cylinder, and I'm going to control P and parent that. And now the cylinder is the wrecking ball. Okay, cool. I'm going to move over here, and if I rotate on the y-axis, we're now swinging like a wrecking ball, and that's because the pivot point is up here. Let's make it animated. So if I open a new window here, go to animation nodes. If you don't have animation nodes, then download the add-on and enable the add-on. I'm not going to show it at the moment. So let's make a new node tree. And go here. I'm going to turn always off, and I'm going to turn these three on. And let's Control A. Let's get a time info. This time info is going to tell us what frame we're on. I'm going to grab a viewer. I'm going to pump that in there just to get a visual of what's happening. As I move the frame so you can see what frame we're on. Additionally, on this item, I'm going to add the end frame, and then the end frame is going to show us what this value is, the end. It never changes, no matter what the frame. I'm going to change this to 100, and when I change the frame, it updates. Cool. We're going to use this to tell us, divide numbers, the progress of our animation. If I divide the frame and the end frame, plug that in here, now we know how far along on our animation we are. Once we hit 100, we're at 1. Once we're at 50, we're at 50%. Okay? Pretty straightforward. You can grab a constant, 2 pi. Also, I'm going to turn on snapping because I think it'll make everything more lined up and beautiful. Now I'm going to multiply this value by this value. And if we plug this in here, get that out of there. As we go through, we're now going from 0 to 2 pi. When the animation completes. Next, cosine, no. Math, float math, get a cosine, feed that into here. Now as we look, the beginning of the animation, we're at 1. Halfway through, we're at -1. And then at the end, we're back to 1. we have a perfect loop between 1 and -1. Let's get a transforms output. And we're going to click the eyedropper since the wrecking ball is selected. That will control that. We want to control the Y rotation like we did earlier. If we feed this into here, I'm going to use degrees, and instead of X, I'm going to feed this into the Y. Let's look at this and let's go through the animation, and it is working, but it's way too low. So I'm going to get another math node, make that a multiply. I'm just going to get a float input so that I can dictate how much swing I want. So let's throw this value into here, switch this because I'm anal, and put this into here. We can move these over, something like that. Feed this into here, and I think I like 70. Now we're going from, at the beginning, 70 to -70, all the way back to 70. So if you play it, you've got this really nice wrecking ball animation. And the nice thing about the cosine is that, like, as it approaches 1, it slows down, and as it leaves 1, it speeds up, and you get this pretty nice looking swing. Let's add some boxes to smash. Oh, but first, I'm just gonna say, like, I'm gonna take this, I'm gonna call it like swing value, something like that. Maybe get in there and change the color a little bit. Oh, nice. Just to have something that kind of differentiates it. Cool. And let's frame it while we're at it. Let's keep everything really straightforward. Let's say wrecking ball. We can just throw everything in here. Cool. Wrecking ball. Now, in order to make some boxes, first I'm going to make I'm gonna make an empty plane axis, and this empty is going to be our box position. So I'm gonna call this box position 1, and this thing is going to dictate where my box is. And I'm using this because at first we're just going to play with a big box, but then we're going to divide that into several boxes, and I want to use this plane axis to tell all of those boxes where to be and when. We need to move this plane axis along on a conveyor belt. As you can see, it's not moving. So the first thing I need is a float input. Maybe put that to like 1. And this is going to be the speed of the conveyor belt. In fact, I'll just get in here and call this speed. Close that down. And I am going to make a transforms output and click the eyedropper to get the box position 1, and I want to control the location. I'm going to make a group because I know that I'm going to do this for more than just box position 1. I'm going to make it for position 2 and position 3, and I'm going to want to duplicate this logic. So I'm going to make a new node group input, and this thing is going to be called like conveyor belt movement, something like that. It's going to take a float, which will be our speed, and it's going to output a vector. That's going to tell us the location. Okay? So then we can conveyor belt movement, this over here, invoke subprogram. We're going to put the speed into here, and then this is going to tell us the vector of our position. What we need now is to know what frame we're in, so we get another time info, throw that up here, and the object is going to move along the conveyor belt at a consistent linear speed. So each frame it's going to move this speed value. So we're going to multiply this frame by the speed, and then we're going to put that value into the vector and make sure that we are using the y value, not the x. And now it moves one every single frame, which I think is a little bit fast. So I'm going to put this at 0.3. See how that goes. Okay, that's much nicer. Now what's the issue here? We want this thing to be at 0, 0, 0 at a certain frame so that the wrecking ball hits it. We need to move this thing back a certain number of frames so that it is at 0, 0, 0 on what frame? Well, let's find out what frame. I'm going to create a cube. I'm going to put it at 0, 0, 0. And I'm going to look at the front view. I'm going to move here, and I'm going to find that the wrecking ball makes contact at frame 22. So I'm going to make a new integer input. And this is a hit frame. So I'm just going to call this hit frame. I'm going to say 22. And I need to feed that into my subprogram here. So I need a new integer. Call this hit frame. Ooh. Booyah. I'm going to throw this into here. Now, yes, I'm going to multiply this. And I'm going to multiply the speed by the hit frame. And I'm going to subtract that. I'm going to subtract these two. So I'm going to subtract this and this. Why am I doing that? Well, let's look at a viewer here. So this value, this is constant, 6.6. Doesn't matter. This is the distance that this box is going to travel in 22 frames. This value, however, is not constant. It changes. This is the value it has traveled. So it has traveled 0 at frame 0, and it has traveled by frame 22, 6.6. So by subtracting this value from this value at frame 22, we are at 0. And we actually need to plug this into here to see that work. So now, oh my goodness. We need to get rid of this combined vector. We need to attach this to the y, and then we need to go here. Okay, now you can see this thing, and I'll just move this box over to the x, and you can see this thing is right where it needs to be when it gets hit. Boom! So let's clean this up a little bit. I don't think we need that viewer. Cool. So now let's instance this cube on top of this plane axis so that the cube is moving along. I'm going to move down a little ways. I'm going to get an object instancer. I'm going to select the cube, and if I hit 1, now there's a new cube here. This thing is being copied right here. I want this to be at this plane axis, so I'm going to need a transforms input, and I'm going to select box position 1. This tells me what location this is at, And then I need a transforms output. And I'm going to select the location. And I'm going to feed the objects list. It's a single object, but it's a list of one object. And I'm going to feed in the location here. And voila. This is now moving with the axis smash. And then once we loop, boop, it hits every time. God, that's nice. That is so nice. Okay, what's next? Let's move this speed down. We are going to copy this down here. We need a new box position. So I'm going to duplicate this. And hey, I have snapping on in here too. That's cool, I guess. I didn't want it to be, but I don't care. It doesn't matter. I'm going to click the eyedropper, and now we're controlling box position 1.001. I'm going to rename this to box position 2. And we want this one. This one should be moving. Oh, see, we got to feed in the speed, so we'll give it the same speed. Now, this box position 2 should be moving at the same exact rate and in the same position as box position 1. Why is that? Because the hit frame is the same. So if we look at this and we analyze, let's Control M1 and let's look at this. So the second time it hits looks like frame 72. So we'll pump in 72. We look at this and voila. Wait, where are we? Yes. Now, our second plane axis is hitting exactly where we want it to. Beautiful. And we can just go down here. We can duplicate this logic. Move it down a little ways. And we're instancing this cube, but we want it to be at the second position. So now we have two cubes, smash and smashy. But as you can see, it doesn't really look like a perfect loop. So let's get in here, duplicate box position 2, call it box position 3, and you guessed it, duplicate these, feed the speed, change this to box position 3, and then what hit frame do we want this to be? Well, this is 50 greater than this, so this should be 50 greater than this. You can pump in 122 if you like, but there's a better way that we will look at real quick. We're going to duplicate this again down here, and we're going to say box position 3, and now let's look at this. 1, 2, 3. Now that is seamless and beautiful. See how the origin is showing? That's box position 3, and then the origin disappears. That's when it loops and it becomes box position 1. You can see that it's actually just flying back. But it looks seamless. So cool. Okay. Now, what's really cool about this is you can change the speed. You can speed this thing way up, and everything is going to hit at the exact right time. You can slow it way down. And everything is going to hit and look exactly right. It's pretty tight. Pretty tight, if I do say so myself. Say you want to change the frames to 200. Now everything's off. If you play this, we miss. You know we're going to miss. Yeah, we miss. You have to update the hit frames. So I'm going to look at this. I'm going to find where it hits. Looks like it's hitting on frame 43, 44. Let's just say 44. So I need to do frame 44. Okay, I did frame 44 up there. I'm going to find this. I'm going to look at that. That's frame 144. And now I've got to do this super hard math in my head. 144 minus 44, what is that? 100. And then I have to add 100 to this. So that's 244. Super hard. You can cut down on a little bit of work here by having the animation nodes do the math for you. If I create a new math node and I subtract this hit frame from this hit frame, and then I add this value to this value, then I can just feed this into the hit frame, get rid of this, and at least our third hit frame will be calculated for us. So if we look at this, our third hit frame is accurate. If we go back to 100 frames, and we return to 22 and 72, our third box will be accurate. Okay, let's add a really simple conveyor belt. I'm gonna create a cube. I'm going to squeeze it down. I'm gonna squeeze it down on the z-axis. And move it down to about there. Let's turn snapping off. Move it up, something like that. Scale it on the x-axis, and then scale it on the y-axis. I'm going to keep it small here for a second, just so that we can, since we're in object mode, it's hard to tell when this thing moves when it's really long. I'm going to rename this to conveyor top. And we're going to take this, duplicate it down. Conveyor top is selected. Oh, we don't want to affect the z value, so let's take the x and the z off. We just want to affect the y for this. I'm going to look at this and GZ, move this down. Okay, that looks about right. And we're gonna feed the speed. Feed the speed. Hit frame doesn't really matter. It'll just, since hit frame is 0, then our origin is gonna be at 0 on the 0th frame. Now, let's stretch this thing out, and you can see, if you kind of look at this view, it moves at the same exact rate as the boxes. Excellent. Then we can go here, duplicate this thing, move it straight down on the z-axis, and we want this to move the opposite direction because this is the conveyor belt bottom. Bottom. We want to move this. We're going to copy this down, conveyor belt bottom, and we want this to go in the opposite direction. So I'm going to create an invert number node, and I'm going to feed the speed into here. Now this is going to make the bottom move in the opposite direction. Now you won't really be able to tell in object mode too well that anything's moving at all, but when we shade this, it will be obvious. Great. let's knock these blocks around. In order to do that, I need to start getting into rigid body stuff. So let's make this ball a rigid body. Here, rigid body, active, animated? Does that matter? Yes, let's make it animated. Cool. I'm also going to make the conveyor belt top a rigid body but passive. Then I'm going to take this cube, and since these are all instances of this cube, I can make them rigid bodies as well. So let's go back to here. Now they're not rigid bodies yet. If you look at it, it doesn't have a rigid body. Right, in order to get this rigid body onto this instance, we're going to have to copy the full object, and that is going to put the rigid body on the instance. Now if we watch this, boom, it's not moving. Why is it not moving? Because we're trying to animate it, but it's part of the rigid body world, so we can't animate it. So what I'm going to do is I'm going to go here, I'm going to put animated to true. I'm going to click this off, click this back on, and this is going to copy that animated checkbox over, and we can move it. Now, what's the problem? It's just animated, and we're not like using the physics. One thing that you might think to do is to keyframe this animated checkbox. You can actually keyframe this to be animated until the hit frame, which is frame 22 in this case. However, a couple of problems there. The keyframing doesn't copy over in the instance, even if you do a deep copy. We have to do separate keyframes for each of these instances. So what are we going to do here? We're going to make a script. This is a super simple script, but it's a very cool way to interface with animation nodes. So I'm going to create a new script here. This is going to be called my script, and I'll call this script node to animate or not to animate. That is the question. So let's pull this up. Ooh, come on. Come on. There we go. And let's go to text editor. Open up my script. We need a list of boxes. So let's get an object list. And we'll call this boxes. And we also need the hit frame. Oops, not that. We need the integer, which is our hit underscore frame. I'm using Python naming syntax, and that's why I have the underscore to separate the words. All lowercase, not that important, but I'm a stickler. I'm going to create a new node to animate or not to animate. I'm going to feed the objects into here. Now there's only one box, but eventually there will be multiple boxes, but for now this is a list of just a single box. And I'm going to feed the hit frame in from up here. Just like so. Okay, let's move back to the 0th frame, and let's look at this script. We're going to loop through the boxes. So for box in boxes, now we have access to each box in the list, which is only the one box at the moment. We're going to say box dot, and we want to access this value. So I'm going to right click this, and I'm going to copy data path. This is going to give us the information we need to paste right here, rigid body dot kinematic. And we can set this equal to true, and in that case the animated box will be checked. So if we run this animation, it is true, it is checked. Go back to the beginning. Now if we were to say false, save that. Now, as you can see, animated is false. And it doesn't actually move. All good. Now, we want this to be checked conditionally. For all the frames leading up to the hit frame, 1 through 22, or 1 through 21, we want this thing to be checked. At 22 and beyond, we want it to be unchecked, because we're no longer animating, and we're smashing it with this wrecking ball. How do we do that? Well, first we need to know the current frame. So I'm going to get the current frame, and you can look up how to find the current frame on the documentation, but I know because I've done this too many times now. Context scene dot frame current. And I'm setting this to the variable current frame because this is just way too long and I just want to have an easy way to reference this. And I am going to change out false for current frame is less than hit frame. That hit frame is being fed in, it's frame 22. So when current frame is 1 through 21, it is less than hit frame, and this will evaluate to true. When current frame is 22 and beyond, this will evaluate to false. And so if we look at the animations, animated, 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 and then on frame 22, we're not animated, and the rigid body takes over. Boom! Oh, too fast. Just play it. Boom! Oh, hopefully that wasn't too loud. Boom! And as you can see, the box position continues on. It is no longer part of the animation, but it's good to know where you're supposed to be at any given time. Great. Now we can do that for the next box. We can just basically we don't even need this script anymore. So I'm gonna. You should probably save this script too. So if I go to text, save as, tutorials wrecking ball, I save this as, I'm just going to save it as my script. You have to save it separately, or else I think it won't be there when you reload your project. Just know that. Do that. Join areas. Close that down. Now we can duplicate this. We can put the objects in, and we can take the second hit frame, feed that into there. Move these down a little bit. Cool. I'm going to turn snapping on again because I like it. Great. Now this should smash 1 and smash 2? No? Why is that? Because we haven't copied the full object. So let's go back to the beginning, copy the full object, and 1, smashy. Boom. God, that's so satisfying. I mean, we're practically done now. Oh, we don't want to hit the original here, so let's move this over a little bit more. Okay, who cares? Whatever. Great. And we're not going to do that for the third one. We don't need to copy the rigid body over, which is pretty convenient that we don't have to copy that over because it's just for show. It's just for looks. Wow, this is coming along quite nicely. Smashy, smashy. Let's separate out these boxes. First, I'm just going to move all this stuff down a little bit. And then in order to split these boxes, it's gonna get a little weird here, folks. It's gonna get trippy. But I think you're really gonna enjoy this part, because I have, and if I have, you must. You must. Okay, to split these boxes, I'm going to do this separate from the whole animation so far. I'm going to hide everything else, and I'm just going to focus on this one aspect because it's a bit complex. I'm going to duplicate this instancer, and this is going to give us one copy of the box, and we're going to just play with breaking this thing up. I hit the slash key in order to just look at this one box, and I'm going to want to know how many divisions I need to make this. So let's get an integer input, and let's call this divisions. So when this thing is at like 23 divisions, no, that's ridiculous. 2 divisions. We're gonna be splitting this thing down the middle and down the side. So that's 2 divisions. That's gonna be 4 on top. It's gonna be down the middle and on the side. It's gonna be 4 on the bottom for a total of 8 cubes. Essentially, we're going to be cubing this number. So when we make this 3, we're going to have a 3 by 3 grid here, a 3 by 3 grid in the middle, and a 3 by 3 grid. So it's going to be 3 cubed, which is going to be 27. The easiest way to do this is going to be to do it in 2 dimensions first. So let's just pretend that we're doing this in 2 dimensions. We're going to split this in 2. And we're going to want to do this multiple times. So I'm going to make yet another node group here. Group input. And this we're going to call split boxes. And the input is going to be an integer, which is divisions. And we are going to want to output a vector list. This is going to tell us the position of all of the boxes. And it's also going to tell us the scale. Call this locations. And then we're also going to get a float, which is just going to be the scale of the boxes. So the scale is actually the easier part. The scale is essentially going to be the reciprocal of the divisions. What does that mean? Reciprocal number. I'm going to feed in the divisions, and let's get a viewer to see what's happening here. This divisions is none. Why is that? Because I'm not using this split boxes. So let's feed split boxes the number of divisions here. Okay, so there are 2 divisions. The reciprocal of that is 0.5. I'm going to move these up so everything's a little bit closer. The reciprocal of 3 is 1/3. Reciprocal of 4 is 1/4. Basically, you're putting 1 over whatever this value is. And that is going to be the size. So like if you think about this, if you were to split this with 2 divisions, then each cube is going to be half the size. It's going to be half the width. It's going to be half the height. So we can use this reciprocal and feed that to the scale. And then let's get a transforms output . feed the scale into here, the objects into here, and for now we only have the one object still, single instance, and then this vector is just going to change every value x, y, and z to 0.5 and feed that into the scale. So as you can see, these are a third the size, these are a quarter the size, these are a fifth the size. And when I say these, I mean one. There's only one. Next, we're going to start wanting to play with the positions here. Play with the positions, create the positions. I don't know, whatever you want to call it. Let's create a grid mesh. This thing is going to make our lives really easy. First thing I want to do is I want to get a object output for this mesh. Close this down. I'm going to feed this mesh into here. I'm going to create this target, and I'm going to turn that mesh on. What are we looking at here? This has created this grid, this 10 by 10 grid. We can change the number of divisions. Oh, I cannot change the number of divisions in edit mode. I have to do it in object mode, but you can't really see the difference. So I'm going to do a little trick here. I'm going to add a modifier. I'm going to add a wireframe modifier. I'm going to up that strength a little bit, maybe to 1. Whoa, that's huge. That's insane. No, something like that. Click off. Now I can change these values and see what's happening on the grid. The X and Y, if I were to change X and Y to 2, for example, now I have 2 here and 2 this way. The grid is 2 by 2, and I have these vertices. This length refers to the total length of the grid, 10 by 10. And so nothing ever, like, the length always stays the same. What I want is step, though. Step. Step is actually referring to the size of the cell. So these are each 1 by 1, and the whole grid will change in size because if I change the X and Y, because this refers to the cell size. Now, if I split this box into 2 divisions, then this grid right here is going to give me, in 2 dimensions, it's going to give me the vertices that I need. It's going to give me this and this, this and this. Now if I wanted it to be 3, now we have all 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this grid is going to help immensely. We're just going to feed the divisions directly into this. And as you can see, now we have our 5 by 5 grid. And we are going to, I think we just need a mesh. Oh my goodness. Control A, mesh info. We're going to feed this into here, and then we're going to pass the vertices. And now I just need to turn this on, and then I can feed the locations into here. And voila, we're starting to get this thing to work. So this is giving us a list of locations. In fact, let's create a new viewer node. We can look at the locations here, and this is giving us all 25 of these locations. If I were to shrink this down to, say, 2, always try to keep it really simple when you're building things up. This gives us all 4 locations. And in fact, I'm going to clean this up a little bit. I'm just going to move this over, move this here, move this up here. This is not that important. Move this and move this down. I'm going to move this over here, and we're going to look at this list here. Okay, we don't need this. Okay, now, problem is that we only have the one cube. Since we're thinking of this in 2 dimensions, we are going to square this. So let's take this math node, let's duplicate, let's go to power, we'll square it, we'll throw this value into here, so now 2 squared is going to be 4, and we're going to throw that value into here. And now we have our boxes, just 2 of them, but they're split. They're split and they are positioned perfectly. Let's see what's next. Every time I get to a certain stage, I like to check to see that things are working on with another number, and in fact they're not. They're close. They're looking pretty decent, but we need to squeeze it in a little bit. How do we squeeze it in? Well, the secret lies in here, this value. So we want to squeeze this a little bit closer. Looks like about 2/3. So I'm going to type 2/3 here, and that looks good there. What if we were to change this value to 4? Okay, this needs to get squeezed in a little bit, down to about, looks like 0.5 by 0.5. Okay, so what's the relationship here? It was 1 when we had 2 squares. It was 2/3 when we had 3 squares, and it is half when we have 4 squares. So what I'm going to do is, this isn't going to be correct, but I'm going to throw the reciprocal in and the reciprocal in, and I'm going to see what that looks like. I'm going to shift right click to make a node here, and let's have a look at 2. What's happening with 2? Okay, so here's 2. We know this value is half, and it should be 1. If we look at it, we can see that each box is overlapping at about half the length of the box. And so if we change this value, this value is 2. So like I said, boxes are overlapping at about half. 3 overlapping at about half. 4 overlapping at about half. So let's just stretch this out. Let's just multiply this value by 2. 23. 2. Let's throw that in there, and voila. We have this perfect grid. It looks beautiful. We're really happy. We're really content. We can go up as much as we want, and everything looks amazing, except for one thing. We're only in 2 dimensions, so let's go up to 3 dimensions. How do we go to 3 dimensions? Well, we need more vertices. We have this grid, and it's giving us 2 dimensions. The 3rd dimension, in the case of this current 2 division split, we're going to need 4 more vertices, and they're going to have to be on top of the current. We already have the x and y of all of the vertices we'll ever need. We just need to duplicate these, and we just need to move them up. In order to duplicate them, I'm going to repeat list. No. Goodness. Repeat list. And let's see here. Let's move this down here. Let's move this right here. We're going to repeat this list. We're going to send the vertices in here. And let's duplicate this. And now there are 20 items in this list because the list repeats 5 times. If I go down to 0, the list is empty. If I go to 1, we have the original list. But if I go to 2, this list repeats. So 0 and 4 are the same. 1 and 5, 2 and 6, 7 and 3 are the same. I could ping pong it, and in that case, 3 and 4 will be the same, 5 and 2 will be the same, 6 and 1 will be the same, 7 and 0 will be the same. I'm just going to loop it though. It just doesn't really matter. So now, let me get out of here. Where was I? We now have like the 8 vertices we need, but we need these z values to go up. How do we do that? We're actually going to want to loop through these values, and we're going to want to push them up. So I'm going to click on this repeat list, and then I'm going to hit W, and it's going to give me a loop through list. This creates a new loop input. We're getting ever deeper into this hole. I'm just going to put my loop down here. I'll even change the name to like move dem verts up. I'm going to create a new output. This is going to be a vector list as well. And if I just feed in the vector to the vector, then this value does not change. Let's move this up a little bit so we can see how these things change. Now, if I were to create a vector math node, throw this in here, and now I can change these values. Oh, let me do this. Okay, we have this, this. Let's move this down. Let's move this here. Let's duplicate this here. Put this in here. Now, after running through this subprogram, I can control the values of these. And in fact, if I plug this into the locations now, I can actually move everything up and down like this. But again, we're controlling everything, and we only want to control these last 4. How do we just control these last 4? Well, the secret is floor division. Let me grab a new viewer. In case you're not familiar with floor division, if I take a value, if I take, well, let me get this float math, and if I divide the index here, this is the index 0 through 7. If I divide this by 4, okay. Let's forget the index here. This is what we're going to feed in, but let's imagine we've got the let's pretend this is the index. Let's feed this in here. Now 0 divided by 4, 0, 0.25, 3, 0.75. Okay, this is normal division. 4 is 1. Now, if instead I am on the second, this is 0.5. If I use floor division, this is going to wipe away the 0.5, and we're just going to be on 0. And we're going to be on 0 from 0 to 3, and then once we do 4 divided by 4, now we have 1, and it's going to be 1 until we hit 8. But there is no 8, so we're only going to get 0 and 1 out of this. So let's do some floor division. We're going to divide by 4, and we are going to, now we know whether we're in these 4 or these 4, and we are going to multiply. Let's multiply numbers. We're going to multiply this value by, I'm just going to say 1 for now. And then we're going to feed this value into here. That's going to give us a new combined vector, and we're working with the z value, so let's move that over there. Let's move these down, move this up. Let's get this stuff over here, move it down a little bit. Now we're only controlling these 4 values. We can move them up, we can move them down. Very nice. Why aren't we seeing, so we have 8 points here, why aren't we seeing 8 cubes? Because we're only creating 4 cubes. We need, since we're now in the 3rd dimension, we need to not square this, we need to cube it. And we have our 8 cubes. Looking good. Looking really good. Now let's try, as always, to try it with 3. And we look like garbage. We look like absolute garbage. Why? Why is that? Because for a number of reasons, actually. So the one thing is that this is being divided by 4. That was assuming that there are only 4 things on the bottom, and as you can see, there are 4 on each layer here. So we want this to be 9 in this case. How do we do this? Well, we need a new parameter, an integer, and we need this integer to be the divisions. And we need to feed the divisions into this loop. So the divisions are being fed into this subgroup, and then the new divisions, where are the divisions? The divisions now need to be fed into this divisions. So now we feed this divisions into here. Now we have access to it here. And for this, we're going to duplicate here. We're going to power. For this one, we are going to square it because we just want 1 layer. We're going to square the divisions. Then we're going to feed that into here. And that is going to give us 9. And if we were to go up again to 4, 5, that's going to give us the correct number for each layer. So now we have a couple of problems still. We only have 2 layers, and they're all spread out. So let's get the 3rd layer. How do we get the 3rd layer? Well, we need to repeat this list more than 2 times. That's why, because we're only repeating the list 2 times. We need to, in this case, repeat it 3 times because there are 3 layers. How do we do that? Well, again, we just feed the divisions into here, and now we have our 3rd layer. Perfect. Okay. And now we want to squish this thing down. How do we squish it down? Well, we basically need the same spacing between these as we have between these. Where did we get that spacing? From this node. In fact, I'm going to name this spacing. That's what I'm going to do. Spacing. Now, I'm going to feed this spacing into this loop. Move dem verts up. In order to do that, I need to get a float. I'm going to call it spacing, and I'm going to feed this value into here. Then, instead of this 1, I'm just going to feed this into here. And voila. God, this is looking good. This is looking so good. Okay. Let's clean this up a little bit Okay, we got this here, this here, this here, 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 and here, something like this. I'm gonna frame this thing. Add frame. Move this into here. And this frame will be move them verts up. Loop. Okay, I'm gonna get rid of these just to make this look a little cleaner. We don't need this mesh anymore. This was just kind of our guide, so I'm gonna get rid of that. Target was the object. I'm gonna get rid of that. And now we've got these divisions. We've got the reciprocal. This here. I'm gonna get rid of that. I'm just gonna go. No, I'm not. Okay, and then I'm gonna move this here and this here. Invoking this subprogram. This here. I'm gonna make a new frame. What was this? It's called split boxes. Make a new frame. Move all of these. Oop. Into here. And call this split boxes. Really good to keep organized, especially when things get this complex. All right, one last thing is bothering me about this. They are too high. I want this thing to be centered on the origin. So I'm actually gonna bring it down. How am I gonna do that? I am basically just going to do a vector math node. Oh, excuse me. Excuse me. I'm gonna subtract and I'm gonna feed these locations into this, and then I'm going to feed these locations into here, and now I can control the z value of all of them like so. So where do these need to be? Let's go back to our simple example, 2. We need this to be at, looks like 0.5. For 3, we need them to be at, looks like 2/3. And for 4, we need them to be at, what, 0.75? What is the relationship here? Well, I'm just going to cut to the chase. We're going to take the reciprocal. Wait. We're going to take the reciprocal, but we're not going to do that here because we've already got the reciprocal in the subprogram, so we're just going to do it there. We're going to take this reciprocal and we're going to duplicate this, move this up a little bit. We're going to subtract 1 from the reciprocal. Okay, so reciprocal, 1 minus the reciprocal. Then we're going to move this over and get that vector math node. We're going to subtract, and we're going to take that vert list. We're going to put it here. We're going to take this. We're going to subtract this. I'm going to subtract it on the z. I'm going to put this here. I'm going to take this and put this here, I suppose. I can just shrink that down. And we're going to put this in here. And now, no matter how many we have, everything is centered on the origin. It's perfect. It's beautiful. We love it. We absolutely love it. We can get back to moving things on the conveyor belt. We show everything. this was just an example to build up this sub program, split boxes. So I can go ahead and again, I'm gonna cut this. Do this. I'm gonna delete these. Move this up to somewhere like this. Gonna position our box 3 back now that we have some room. Save this. Move this down. And let's get rid of this instance. Let's change the divisions back to 2. And I'm going to feed this into here. And now we should have 8 boxes. And they're all the normal size of the box. So we want to use our split boxes subroutine. And we're going to put the divisions in. And we're going to try to affect the scale. And now they're all scaled to half the size. And let's just shrink that down. And we're going to use the locations. Boom. Now we have everything. Now the only problem is that this thing, haha, it's awesome. It works. Smash. God, I love it how it just works. Smash. We just want them to follow this until it gets smashed though. So that's why we are using this box position as an input. And I think all we have to do is just do a little vector math. I'm just gonna take this and we're gonna add the location of the box position 1, and that should do it for us. Let's check it out. Let's save this, put this at 0, and voila, smashy smashy, smash. And then the beautiful thing is we can go back to the beginning. We can be like, you know what, I want 3 divisions. And then smashy smashy. It just works. It's so nice. So now we can do something like, let's take these 3, I believe. Let's duplicate them. Let's move this out. Let's grab these 3 again. Let's just put connect everything up. Get the divisions. The scale into the scale, and then put the location into here, and then change the location here, and I think that should be good. No, it's not. Why not? Oh, because we did not update the, see, there's just one. We need to update this to be this many instances. This many instances. This many instances. Boom. Save that, and we get smashy smashy. Smashy smashy. Smashy smashy. Smashy smashy. Smash. Right, and that's going to do it for now for the animation nodes. You can get in here and you can, you know, obviously I've said it a million times before, you can change up the number of things that get smashed. If this thing isn't smashing the way you want it to, maybe see how like these are gonna stay on the conveyor belt. You don't want them to stay on the conveyor belt. You can go back, you can select the wrecking ball, go here, and you can move it along the y-axis. Maybe you can move it back a little ways. Try that. Dude, that's a massive tutorial. I'm not going to do the shaders in this tutorial. Let me know in the comments below if you want me to do a shader tutorial for this particular conveyor belt tutorial. If you like this video, please like. If you want to subscribe, please subscribe. If you want to be notified, hit the notify button. Helps me create more tutorials, and yeah, let me know what you think in the comments below. Goodbye.